Hello everyone, welcome to our channel Wisdom ML. So if you haven't subscribed our channel, so first I request you to subscribe our channel so that you will get the notification of our interesting videos which we'll be going to upload in the next few days. So this is again a very interesting video in which we'll be converting images into cartoonized form, in pencil sketch form, or in the form of pastel color, watercolors. So you can give any type of effect to your image. And you know that nowadays we have lots of web apps or mobile apps available in Android or store where you can transform your image into cartoonized form, right, for creating avatars. And most of the time, there are lots of websites which require you to upload avatars. To give it more unique in terms of your original image, you can create your own account using this web app. So it is coded in Flask, right, in Python only, and we have used OpenCV for providing different types of effects to the images. So let me start this demo of this Flask web app. So here we have two things in the form of input. We have to give one image. Let's say we have taken this sample image of Sachin Tendulkar, and we have to select certain style parameters. So let me select the first one, that is image enhancement. And if you click on stylize, you can see that now the image is quite in the form of enhanced. All the colors are more clearer, right? More you can say darker or clearer, and we have a clear distinction of the colors which we have in this image. So this is the original image, and it is, you can see, quite smooth, whereas this is more you can say original in the form of all the colors, quite realistic looking, right? Now we can check another effect, that is you can say cartoon, right? So if you click on cartoon, so it will convert it into cartoon form. So this is the pure cartoon form. Okay, you can use it in as your avatar or anything. So you have to upload original image of yours, and it will convert it, transform it into a cartoon form. Now another effect we have, very interesting effect we have, that is watercolor. So sometime yeah, so this image is quite unrecognizable in the sense we have applied watercolors into it, but it is realistic in the sense by looking you can see that, yeah, we have applied watercolors into it. So what the main purpose is here is that how it's actually doing is basically it is taking the retrieving the edges of all the colors where we have the color differences, right? So it has clearly marked all the edges with you can say proper coloring, black colors, and applied random colors into it, okay, with watercolors. So this is a complete different outlook of this image in the form of watercolor. Now again we can check another effect with, we can say, pastel colors. It is somewhat similar to a cartoon effect, but here we have some differences in the colors, and somewhat it is looking like pastel effect. Right? Now let me do another very interesting style, that is pencil sketch. So if we want to convert our image into the form of, let's say we have drawn anything with using pencil. So this is the one, right? In this you can see we have clear outlining of all the edges, and it is having proper shadings we have given like we generally do while drawing, right? So it is quite exactly matching with any drawing image if we draw any image by seeing the original image. So this is also very quick utility to transform your image into a, you can say, your drawn image. Again, so in this pencil sketch method, we have two outputs. One is the drawn image or grayscale image, and the second one is the color pencil image, color pencil effect, actually. So where we use color pencil. So here the basic outlining will be same, but the colors are somewhat sampled and applied randomly to different edges or shades. So this is our app, okay, where we have multiple styling options, and you can also add your own custom styling effects, which are also available in OpenCV, or maybe you can use your own. So like that, you can build your own website for basically styling any type of image. So it's a very good utility, you can use it. So now I'll quickly show you the notebook where I'll explain you what effects we have used. So here we have used basically, first of all, we are opening this image from Wikipedia. This is the image we have used, and converting it into a NumPy array in the form of byte array, because while reading any image from the URL, we have to convert it into byte array so that we can decode it using CV2 and then we can show it. So this is our image. Now, first one is the detail enhanced filter. Here we are actually using two parameters, and this detail enhanced method is actually defined in OpenCV and the CV2. So here we have three parameters. This is the image source. This is the sigma s and sigma r. So what this sigma s is doing here is that basically it is the smoothing parameter. Okay, and what it do is basically it smooth the pixels by taking the average of the neighboring pixels. Okay, so this is the that's why it provides smoothing effect. But if we do randomly smoothing over all the image, then the colors will be mixed here and there. Okay, so for controlling that part, this is sigma r, which maintains the color distinction. So that if we are applying smoothing by taking the average, weighted average of the neighboring pixels, so it should not mix this to this. So because we have two different colors. So if we put this value towards higher side, then what will happen? It will basically increase the one constant color to mix with other colors. So we should keep its value low so that all the colors which are in their original form will remain as original. And this effect will give more smoothing. If we increase it, it will move towards this is like smoothing, right? So to give it more realistic or more enhanced view, we should keep the value lower. Now we have another effect, that is pencil sketch filter. So this is also available under OpenCV with the name pencil sketch, where we have P small, S is capital, and the parameters are almost same, but only one difference. We have another parameters, that is shade factor, and this shade factor value ranges from 0 to 0.1. So if we keep this value, let's say 0.1, it will make the image more brighter, more bright. Okay. While shading, it will remove shading part and makes the image more. Whereas if we keep the value too low, let's say 0.01, it will increase the dark effect or the shading part. Okay, so this is the shading effect. So we should keep it value, you can say, middle of both. So it will give effect of shading as well as make the image brighter also. Again, so in this we get two outputs in return. So this is the image out gray. First one is the gray output, second one is the colored image output. So this is our colored image output. Now we have a very important effect, that is cartoon effect. Okay, and here we have to do certain transformation. So we have to apply multiple transformation for converting it into cartoon form. First, we have to convert the BGR or colored image into a gray form. Okay, because any advanced transformation if you want to do, so first we have to convert our colored image into gray color form, so that we can get the basic edges and all. So in step 2, we are actually retrieving the edges and highlighting them using adaptive threshold. Okay, so this threshold in which we are supplying this gray image which we have created, 255 is the parameter. Second is the adaptive threshold Gaussian technique we are applying with constant C. And the fourth parameter is somewhat threshold binary threshold. And these 9,8 are basically the block size. So this image will be transformed into 9,8 block size, and which we have to later on basically flatten the image and resize into basically reshape into our original image. So next step is color quantization. So now we have basically color the image. We have done the adaptive thresholding, taken the retrieve the highlights of the you can say color boundaries or edges. Now we'll be applying color quantization on the original image, basically, ING. So what we are doing basically, we are actually reshaping, okay, reshaping the images because we want clustering. K means clustering will be applying onto it. And for this, we are using 8 clusters. And we have to provide criteria also. So this criteria, what it will do, it will take the sum of criteria EPS, criteria max iteration and 20,1.0. So this is basically the terminating criteria for creating clusters or iterations for creating clusters. So that's why we have to supply one criteria. And 10, and then we have K means random centers. So these are the parameters we have to supply. 8 is our number of clusters. Now we only need the center cluster, centroid part of it. So we'll be only fetching the center and converting into NumPy arrays, NumPy integer array. Now we have to, that I told you, we have to reshape our image into original size because we have applied k-means clustering quantization effect. We have to flatten it and reshape into a original image size. Now if we just resize it, we have applied k-means clustering, okay, color quantization effect we have done. Now we have to apply median blur because it will smooth the results. Whatever the colors which are more and less at certain part, it will smooth the effect by taking the averaging or median. It's a median effect. Yeah. After blurring it, we have to combine all the results. So for this, we are applying bitwise AND operation, which is defined under CV2. So we are doing actually blurred, comma blurred, and in the mask actually we are supplying the edges which we have created in adaptive threshold step. This, so sorry, this one. Now you can see that when we do bitwise AND, it will convert it into a proper cartoon effect. Now another effect is watercolor. So in this we are actually using stylization method defined in the CV2. Here where we are doing, we are actually converting the default color palette BGR into RGB, proper color format. And by converting into RGB, we are applying stylization on format by setting sigma S and sigma. So it will convert it into a watercolor format, give the effect of watercolor. So these are the techniques we are using for transforming our image into cartoonized effects or some other effects. Now quickly we will move towards the Flask web app. So this is our Flask web app Cartoonizer, in which we have you can see these folders. So some default folders are static templates, and we have file app.py where we have done actual coding. And we have two other folders, cartoon images and uploads. So uploads is the folder we are actually uploading the image, whereas cartoon images is the folder where the output will be stored. Now I'll quickly move towards the app.py part. And in templates, where we have 3 HTML pages which are shown in our, okay, to give the UI part. So next, let me go towards app.py. So this is our app.py page. Okay. In this, what we are doing basically, we are first of all configuring this two folders because these are not the default folders. So we have to keep the folders defined in the configuration, cartoon images and upload. Next, what we are doing is we are basically using our index page slash. This is our first page, index.html. Let me auto it. This is our index.html. And so let me open it. So this base.html page is basically for giving the overall look and feel of the web app. If we want to make our look and feel constant over all the pages, so we should create one base page and we should extend the design and templates, design and CSS in the subsequent pages. So in index.html and predict.html, we are basically extending base.html design so that we don't have to code explicitly the design part into the index.html and predict. Now in the index.html, we are doing certain things like we are creating form, okay, and we are defining the action as slash predict. So once we upload or post anything in this form, we'll be hitting this method slash predict method. So let me go to index. So what we are doing here, basically we are creating a card that is bootstrap card. And here we are using our file uploader. Okay, this is the input file uploader, and this is our drop down select list. So these are the values, and this is our button. So basically, once you click this button, it will do two things. First, it will also upload the image, and second, it will also capture the input which we'll be selecting through this drop down. And once we capture it, we'll hit this predict method and we'll check here whether the method is post. If it is post, we'll be receiving both file and the style from the drop downs. Now what we are doing, we are creating a proper file path because we have to save this file not on the default path but on the actual uploads path, uploads folder, under uploads. So we are using os.path.join, and here we are actually supplying three parameters. One is base path, that is our root directory. Uploads, which is in the root directory, this uploads folder. And then we have secure underscore file name, in which we have to supply the file name by which this file will be saved. And that we can easily do using f.file. Now if we do f.save and supply this file path, then this file will be saved under uploads folder. Now we have a file name, okay, which is actually so what happens, file name is somewhat which should not include the other path variable. So we can easily get through os.path.base name, and we have to supply the full path so that we'll get the file name. Now, because we'll be using it in the later steps. So what happened now here, we are actually creating a object variable using cv2.nameRead, and in this we have to supply file. Now we got our image object. We'll be checking now what is the style we have selected to that. So if we have selected style 1, so we will first create the output image name. So that is file name which we got here underscore style 1 cartoon. So this is our output file name which will be used for saving this style 1 transformation. Next we'll create also the path, okay, that at which location it will store. So this is our cartoon images location. And now which thing we have to store, that is cartoonized, where we actually supplying under method cartoonize underscore 1, we are supplying this img, which is our image object, and 8 is the number of cluster or the block size. So first one is our cartoonize underscore 1, which is our this one cartoon, and here k is the cluster. So 8 we are supplying because we want 8 clusters, okay, sorry, yeah. So we want actually 8 cluster, that's here. So this is our one, and in the cartoonize 2 we are doing stylization, which is watercolor effect. Cartoonize 3 is our pencil sketch, So 3 is the pencil sketch in the form of grayscale, 4 is the pencil sketch in the form of a colored scale, and 5 is the pastel color effect, in which we have changed certain parameters here and there, and it changes the full output and giving the effect of pastel colors. 6 is the detail enhancing one. Okay, so these are the different methods which we are calling based on the style the user has seen. So this is our code. Okay, and so just 2 3 things we have, just the uh, methods and the actual calling method predict. Now another important thing is that we have these images. So now we have to plot these images onto the design page, that is predict.html. So what we are doing is, this is very important. So if we want to plot any image in the design page in HTML, we have to supply it under image tag and supply using like this in Flask URL for, give the name of the image, that is upload underscore img. I'll quickly tell you what it is. And file name, we have to supply file name. Now you will say that where this file name and upload image is coming from. Okay, that also I'll tell you. And in this we are setting class is equal to image fluid. So what it will do, whatever the class we have created, right, div class green and the div class blue, and you can see this. If we do, let's in again. So if we do, let's say cartoon. So this what image fluid will do, it will keep the image within this div only. Okay. So that is the effect of this class image img fluid. So now we'll quickly see from where it is coming actually, upload image and cartoon image. So it is coming from basically here, this method. Okay, upload underscore image and cartoon underscore image. So if we want to plot anything which is not in the default folder, or if it is custom folder, if it is present in custom folder, so we have to define like this, where we use send from directory method, which is defined in Flask only. From Flask, this send from directory method is there. And here you have to supply your configuration from which folder actually you want that file name to appear. That file. So for upload folder, which we have uploaded, we are using upload image and using upload folder, and with upload folder it is finding that file name. Similarly, in the cartoon image, it is finding under cartoon folder and file name which we have created. So once we do any transformation in the product here, so we are actually giving 2 things. One is the cv2.im, right? Here we are actually writing the path of the image, and here we are setting the file name. So file name is somewhat the original file name, whereas cartoon file is the f name which we have just created. So that we get both the names, file underscore name, f name. And we are rendering this on predict.html. So if you see predict.html, we have both the names, file underscore name and cartoon underscore file. And very important, we have to keep all these things under double curly braces, so that we can supply all the things which are there in the. So I hope guys you like our video, and this app will help you in building your portfolio in computer vision side. You can build very good utility app by doing more customization on it. So thanks guys for watching our video, and if you have not subscribed our channel, so please do subscribe so that you will get the notification of our upcoming more interesting videos. Have a good day.